right, ladies and gents, we do not have much time, so we should probably dive in pretty quickly. I should probably get Noah Jones out of here. So, homework. 1, 2, 2 was going to be today's homework, right? That's what it was supposed to be. It still can be if you want, but now that I'm thinking realistically, I doubt we get through the packet this week because half-hour classes just aren't long enough. So to put it in writing, realistically, we probably won't finish that packet this week, and I don't want you guys to rip it apart because I want to collect those 4 things together. So I'll probably wait to collect that till next week. So we're just going to keep working as quickly as we can, but not like quicker than we can, right? That's not realistic. So if you want to do 70 to 74 today, sweet. If you still need to finish 1, 2, 1, do that. Right? If you still need to finish 1, 2, 1, do that. So you should have this on your paper from yesterday. And I just got reminded the one other thing that I forgot to talk about. At least I think I forgot to talk about it because I get mixed up with who I told what to. So you might want to jot this down. It could just go anywhere random in your notes. Yeah. This is totally separate from probability, but it relates back to your homework. Sure, look at it. Or grab a piece of graph paper. Unit price. If we want to calculate the unit price, and that means for one, so like for one object, is always the total price. So actually, we could really just use the dollar symbol there. Divided by quantity. So if I paid, I don't know, $48 for 4 pizzas, and we do that division, what's 48 divided by 4?
12.
Thank you. So that tells us it is $12 per pizza. Right? That's how we do unit price. So if you were doing the notebook problem, where it told you about 5 notebooks, the notebook just made me think about the movie, The Notebook. If you were doing the notebook problem, you could figure out the price of 1 notebook and then multiply by how many you want to buy. So back up here, though, where we had this range of impossible to certain, can anyone remind us why this goes from 0 to 1? Like what 0 means and what 1 means, and like I've got a poster here as a reference point too, but Lucas?
Probability, like if you have, if like back to the yogurt problem that we've seen a lot. Like there's 4 yogurts, right? You have a 1/4 chance of being vanilla. There's 4 different types of yogurt.
They're all different, yeah. So
1 out of 4, right?
So what does a 0 up here mean then?
0 means 0 probability.
So can you give me something that has a 0 probability?
That every person will be able to fly.
That we fly home, right? That we leave school and we literally just flap our wings, right? That we don't have, and we fly home. That's a 0 probability. Can you give me something with a probability of 1, John?
Like certain, like it will happen.
Yeah, give me something.
Okay. Say you have a coin that's heads on both sides. You flip a coin, you're always gonna get heads.
So I'm gonna change that a little bit and say, or anything, if I let go of something, we know with certainty gravity happens, right? So like gravity is always going to make, when I flip a coin, I don't really, because normally, what do we use coin flip to normally reference? What? A 50-50. Thank you so much. So, a 50, guys, I'm going to write this in a way that looks wrong. I'm going to tell you, this is not subtraction. This is how a lot of people write a 50-50 probability, which really means that there's a 50%, but really that's 0.5. So I would put both of those numbers in the middle. You could, that's also, what fraction would this be?
1/2.
1/2. Yeah, so a coin flip, a normal fair coin with heads on one side, tails on the other, a normal fair coin is a 50-50 chance. So hopefully you have some other things on here. We'll keep coming back to this and placing some other items. I'm thinking about making actually a poster for the class that you guys could just go write on and place things. Yeah, a couple of you are shaking your heads like, oh, that could be fun. So if I go to the store and I buy a lottery ticket, where do you think winning the lottery, winning a lottery ticket, falls on here? What do you think?
Between 50-50 and impossible.
Between 50-50 and impossible? You're actually absolutely right. The back of the lottery ticket tells me the probabilities. As in a lottery ticket, any old, just like you put $1 in the machine, I'm not talking about Powerball or Mega Millions or anything crazy like that. A normal lottery ticket has like a 1 in 4, 1 in 4, 1 in 5 about chance. But even if you win, guys, if I win $1 when I paid $1,
You didn't win anything.
I didn't really win anything. So saying that the chance of winning a lottery ticket's right here, that means kind of.
Research on lottery tickets that you have 0 or 50%
It depends on the ticket.
Yeah, like you can get only $20 to $100 per call.
Right.
Not
Yeah.
like a real money lottery.
This is probably what tripped you up in your homework. When, I forget exactly which problem it was, but when it asked you to talk about, are these different probabilities theoretical or experimental? So we're about to talk about that. So if I give you a spinner, I don't know if the picture's up here. No, actually we'll wait for that. We'll talk about Mike going to the carnival first. Alright, so here's our setup. We're going to talk about this before I give you a challenge. So, anyone want to read? I mean, go ahead.
Mike wants to win a giant stuffed animal at a carnival. He decides to play the goldfish game, which has 3 prizes: a giant stuffed animal, a smaller stuffed animal, and a plastic kazoo. The game is set up with a tank containing 1 green fish, 3 blue fish, and 6 yellow fish.
Alright, pause, hold up. Write this down in some way on your paper. 1 green, 3 blue, 6 yellow. Then each sheet can keep reading for us.
To play, Mike must go fishing. The game is set up so that every time a player goes fishing, he or she will catch a fish. To win the giant stuffed animal, Mike needs to catch a green fish.
So I want you to talk with your classmates, your team right there, and answer these 3 questions. I'm not going to read them out loud because careful reading is part of what we're practicing this year. So talk with your teammates. I think you should only need like 2 or 3 minutes, so probably right at noon is when we'll come back together. So I'm going to highlight the important parts of the question, but you're talking with your group. Cool?
Yes.
So hopefully you have this written down. 1 green, 3 blue, 6 yellow. I'll try to leave it at the top for you. This is a giant if, right? They changed the situation for you. So what fish gets the giant stuffed animal? The green one, right? Green gets the giant stuffed animal. So guys think about B? Oh, now we're writing things down. Were we absent yesterday? Did you fill out a card thing for me before that happened? Was anybody else absent yesterday that needs to do a card for me? Awesome. Jack, 3, 9, 4, 5. What do you want? There you go. So, just like this, on one side, put first and last name, and Layla's just an overachiever. On the other side, you just need first name. But so that when I turn it, it's facing up. Does that make sense? Do you need to borrow a Sharpie or something? Jack, 3, 9, 4. What do you want? Jack, 3, 9, 4. So, just like this. Put your name on both sides. So, one side can just be first name if you want. Layla's an overachiever. She did first and last on both sides.
Well, there's three. There's like two Laylas.
Yeah, you're right.
Wait, what?
And now, the beauty of me having random cards to pick from. Lucas! Man, and Lucas already talked today, but Lucas, what do you think about A? If all the fish in the tank are green, what is his chance of winning?
100 out of 100.
How do you figure?
Because at the top, right, above the questionnaire says, what a giant stuffed animal might need to catch a green fish. So, if all of the fish are green, he has to catch a fish.
Yeah.
Get an animal.
If the carnival dude turns around and I really quickly make all the fish in the tank green, like, no one's gonna lose, right? Every fish that comes up is gonna be green. So, anytime you have a number over itself, that gives you a 1, right? A number divided by itself gives you a 1, which is 100% when we're talking about probability. Any questions with that? Eli, what about B? How did you
Eli's not here.
I thought I saw him earlier. I hope he's not in the wrong place. John, what about B?
You can't catch blackfish because there is none.
Oh, a blackfish. There are no blackfish in the tank. So if you walk up to the carnival game and it says, the blackfish wins the big prize, and you look at the tank and there are none.
3 blue, 6 yellow. Where are the black ones?
Yeah, there are none. And then, Kylie, what do you think about the percent? With the tank set up the way it is, what is our how do we find percent?
Well, it's pretty easy. She went to the nurse.
She went to the nurse. Sorry. Mia, how would we find percent?
I did 1 plus 3 plus 6. Oh, she was 3 out of 7.
What up, dude? 1 plus 3 plus 6. So hold on. You said do. Who did 1 plus 3 plus 6 to start? Yeah, why?
Because the reader preview told me to.
Ah, funny. That's the total, right? We need the total. So what is 1 plus 3 plus 6? 10. So that goes on bottom. Then Mia, what do I put on top? 1. A 1. So is that a 1% chance? No. What do I need to do to make this?
0.5 or no, 0.1.
Careful. Guys, everybody with me, please write down 1 over 10. But then also write down that that is equal to 10 over 100. Because if on top, if on bottom we multiply by 10, because right here it tells me percent means out of 100. Somewhere.
On the end.
No, it was here. So I need to get 100 on bottom, so we multiply that by 10. We do the same on top, and that gives us 10%. Questions? So wait. Farah, what about the chance of winning blue? What's our percent chance of blue? Yeah. What about blue? How many blue are there?
3.
3. So 3 out of 10, what percent would that turn into? 30, right? So blue would be 30%. Class, what about yellow? What's our percent there? 60, because 6 out of 10 would be 60. Any questions? All right. So, crap, I left stuff on the, I'll be right back. I left things on the printer. I have presents for you guys, but I left them on the printer.
If it's a homework packet, then no. I don't think it is. No, thank you. I don't think it is. It's all good. Does anybody have like a riddle or anything they want to share? Alright, hang on. Raise your hand if you have a riddle. I saw yours first, so. Guys, what did the chicken do to cross the road?
Walk. She's taking a trip to Chick-fil-A.
What did he do? No. Tell us.
Alright, so I'm curious if we can all make the same spinner, but different.
Wait, what?
Well, I'll tell you guys.
Yes.
I know you.
I think you guys are working together. That's why we only have one.
Yep, that's why we only have one. So, we are going to make a game. We are going to make a game. Oh, you guys are. Here's what's up. We are going to make a game where we are going to determine a specific theoretical probability. So wait a minute. Before we make this game, back yourselves up. What is theoretical probability? What is experimental probability? So on your notes, let's write out theoretical. And guys, I will not ask you to write this very many times because it's kind of a hard word. I want to make sure I spell it right. There's an H, right?
No.
All right, yeah. It's a weird word. Guys, has anyone ever said to you, like, well, in theory? Like, in theory, this should be easy. Or, like, in theory, this should work. Or, like, or if you watch the videos that tend to go viral on the internet where something goes bad, and people are like, in theory, that should have worked, and then somebody tries to jump a gap and they fall in the lake or something. Theoretical, the base of the word is theory. It is based off what we see. Like a coin has heads and tails. So we say it has a 50% chance. So theory is our prediction based off what we know. So I can actually shorten that up and say, yeah.
I already wrote.
What we know. Whereas experimental same thing, so I'm actually going to shorten this sentence and just put a dot, dot, dot at the beginning. Same thing of prediction based off. So it's still a prediction based off, or based on. Experimental is based off observed, what we saw happen. So, a coin does not have an experimental probability of 50%. We don't know what it is until we do it. have to actually do it. So another thing that you could write for experimental is that we gotta do it. Do the thing, right? Do the thing. For theoretical, we look at the thing. We like think about the thing. We don't do it, we just think about it. It's like when you said, well, I thought about doing my homework. Yeah, I thought about my homework. Never did it. Thought about it. Thought about grading your papers. Yeah, your papers are graded. They're just in a stack over there that I don't want to pass out yet because it's going to be annoying. So, your spinner. Yeah, we skipped it. Here's what I want you to do. We're going to design the theoretical probability so that 40% of your spinner's red. And guys, I've got some colored pencils up here, but like I'm missing most of my blues. So when we go to do blue, we might have to share. The colored pencils are right here. These, if you see these boxes in any of our classrooms, it's colored pencils. 40% red, 30% blue, 1/10 yellow, and the rest should be green. But guys, I would be careful. I would look at the spinner before you start and kind of think about what's going on. We'll take probably the last 3 minutes to do this, and then we'll look at our spinners tomorrow. So somebody's got to keep it for tonight. Okay? So as a group, make this happen and decide who keeps it for tonight. Definitely not moving as fast. What should we do before we start? Yeah, that's a good idea. I like your numbers. Smarter than me. I just try to count and keep track. What are we doing before we start? We're getting colors out. I like that. Ooh, I don't know if that's productive. Showers with each other? Interesting. What do you guys notice about this before you start?
Oh, that was it.
I know it's hard to count and keep track of which one you already counted.
So 40% needs to be red. How did we figure that out? We know it's like 20.
All right, class, let's make sure we all got the same things to start. When you look at your spinner, how many slices are there? 20 slices. All right, keep working, just making sure we all realize there are 20 total there. So if 40%, 40 out of 100, how many would that be out of 20? No, you're good. All right, and to make sure that I respect your time and get you out of here in time for lunch, I got one last thing. Just one last little, hopefully motivational. So, real quick, bring it back. Yeah, that's like my last ditch effort. So, guys, I'm one of those teachers that probably like is too honest with you guys. So I've been kind of like in a funk lately. I don't know if you guys have been like, we started school and we're all still stuck in masks and things are not going as well as we thought. But so I'm reading a book to try to feel better. I mean, it's got a lot of really great quotes in it. So one of these quotes, and I'll probably bring you one each week or something. One of these quotes is up on the board just to think about. I have no idea what this is. We gotta talk later. I'm like in the middle of stuff. So Sorry, got distracted. Here's a quote for you to think about as I continue to assign you homework. Under pressure, you do not rise to the occasion. That statement, that's not correct. Like, under pressure, you don't rise to the occasion. You sink to the level of your training. So when under pressure, you sink to the level of your training. And that is why we practice. Because under pressure, you want to have that training to be able to perform. So one of you keep that. Please don't lose it. Hole punchers over there if you want. Have a wonderful day. We're having lunch. Please give me my colored pencils back if you borrowed them. I forgot to check what microphone it was recording to. That might be a really loud video.